Okay, so when you're asked to find the solutions to a system of inequalities, your solution is going to be a picture. All right, it's the system. It's represented by a graph. So the area where all the shaded regions overlap is the solution set of a system of inequalities. The vertices are solved by solving each pair of systems of equations, and to get those equations, you simply replace all the inequality symbols with an equal sign. Alright, so here's another system, and I promise I'll show you how to type this in on a calculator soon in the video. But what you're going to do is graph both of these equations. So like x squared minus y equals 1. Alright, if you were to put that in standard form, you would see that it would be a parabola with a y-intercept of -1. That would look just like that. And if you test the point, you would see that you'd shade inside the parabola, because 0, 0 satisfies this system here, or that inequality there. Alright, and then if you were to graph this equation, -x plus y equals 1, it would be a line, y-intercept 1, slope 1. Okay, and if you tested a point, you would see that 0, 0 works. So this really red shaded part would be the solution of the system. And the line and the parabola intersect at these 2 points, so those are your vertices, and those are going to be more important later on when we do word problems, when we try to optimize these systems. Alright, so pretty much just sketch the graphs and shade, and the overlap is the solution. Alright, here's another system here. So x plus y is greater than 3, and x plus y is less than -1. Now look what happens when we shade these two. They shade in opposite directions, so that means there's no solution. This region up here represents all the points that work in the one inequality. All these points here represent all the points that work in the other inequality. There's no point that works in both. So when you have two regions that don't overlap at all, right, usually created by parallel lines, it could also be two parabolas going in opposite directions, you're going to have no solution. So that's entirely possible. Alright, and let's see. Right, and there's a flag of Argentina, just because this kind of looks like that. Alright, here's another quick example just to walk you through it. So sketch the graph and label the vertices. So the first graph I'm going to put into slope-intercept form by like adding x to both sides, or subtracting x on both sides rather. So I see I have a y-intercept of 3 and a slope of negative. Oh man, my picture messed up. Okay, so once I put this into slope-intercept form and graph it, when I test the point, I'm going to go back to the original because it's just a lot safer to plug points in there. So if I plug in 0, 0, I see that 0 is less than 3. So I know that I'm going to shade towards 0, 0 in this direction because I want that to be included there. Alright, then I'm going to graph the other equation. I could put it in point slope form, so I get 2y equals -x plus 3, and then divide everything by 2. And now I see that I have a y-intercept of 1.5 and a slope of -1 half. Oh no, what happened? Sorry, technical difficulties. I got my picture deleted. But what I was saying is once you like graph this equation like as a line, you want to use the original inequality to test the point. So if I test the point like 0, 0 again in here, I get 0 is greater than 3, which is not true. So now I'm going to shade in the opposite direction of 0, 0. And I get that this orange part is the part that's shaded twice, so that's going to be my solution. Now notice how it would go on forever and ever like that. That's called unbounded. When you have a polygon, that's like your shape. Like in this case down here, this is like a parallelogram. Alright, that's called a bounded solution set. There's boundaries on all ends. Still an infinite amount of solutions, but it's bounded. Unbounded means it just kind of goes on forever and ever in a certain direction. And both of these solutions are infinite. Solution sets, I should say.